Okay, so example 1 that we were on. So we had a 100 kilogram cart traveling in and striking a 50 kilogram cart, or an 80 kilogram cart that was initially at rest. The 100 was going 24 meters per second east initially, and after the collision going 10 meters per second east. Okay, so we've written our equation down, and this term disappears because the second cart is not moving initially. And we're looking for V2F, so we're going to take our M1V1F over. So it'll become M1V1 initial minus M1V1 final is equal to M2V2 final, and then divide both sides by M2. Okay, so we'll get V2 final equals M1 was 100 kilograms. V1 initial was 24 meters per second east minus 100 kilograms. And V1 final was 10 meters per second, still east, so they can both go in as positive. And then M2 was 80 kilograms. So on the top, you're going to have 24 and 2 zeros, kilogram meters per second, minus 1000 kilogram meters per second. And on the bottom, 80 kilograms. So 14 with 2 zeros over 80, 140 over 8. V2F should equal 17.5. Whoops, the point goes there. Meters per second. And it's positive, which means east. Okay? Example 2, because I promised you 2 today. Example 2 is they're both going to be moving. Okay? So a 5 kilogram cart is moving 2 meters per second north. So 5 kilograms, and its V1 initial is 2 meters per second, and this way is north this time. And an 8 kilogram cart is moving 4 meters per second south. So this is 8 kilograms, and V2 initial is 4 meters per second south. When they collide, after the collision, the 5 kilogram cart rebounds at a speed of 1 meter per second. So the guy that was going 2 meters per second north rebounds. And so his V1 final is 1 meter per second. If it rebounds, it's south. And then the question wants to know, what is the final velocity of the second cart? So we're looking for V2F again. Okay, so you write down exactly the same equation. M1V1 initial plus M2V2 initial. And that's going to equal M1V1 final plus M2V2 final. Nothing is stationary before or after, so no terms go to 0. We're solving for V2F, so we're going to take our M1V1F over. So we're going to have M1V1 initial plus M2V2 initial minus M1V1 final equals M2V2F, solving for V2F. So divide both sides by M2. Okay, so now when you go to fill in your numbers, be careful of positives and negatives. So M1 is 5 kilograms. And V1 initial is going north, so let's call north positive, so 2 meters per second. Plus M2 was 8 kilograms, and it was going 4 meters per second south initially, so it has to go in as a negative 4 meters per second. Minus M1, 5 kilograms, and after the collision it's going 1 meter per second south, so it goes in as negative 1 meter per second. And it all gets divided by 8 kilograms. So we have on the top, just to make sure you're not going to make any mistakes, 10 kilogram meters per second minus 32 kilogram meters per second. And then this negative becomes positive, so plus 5 kilogram meters per second. And that's going to get divided by 8 kilograms. So 15 and 32, so what's that going to be? 17 on the top. So 17 kilogram meters per second, and it's negative, divided by 8 kilograms. And you get a V2F to be negative 2.125 meters per second. And what does the negative mean? Remember, whenever you get a negative number in physics in an answer, you have to tell me what it is. The negative here means south, because we said let's call north positive, and we put our south in as negative. Okay, so that's example 2. So this evening we have a few more practice questions for you. Some with the earlier ones, just the F delta T and M delta V, and I think at least one with these, and then tomorrow we'll give you more with these. Okay.